You are welcome to the course series on electrolysis. Under this series, we are going to look at Introduction to Electrolysis, which includes definition of electrolysis, importance of electrolysis. 2. We are going to look at the principles of electrolysis, which includes electrolytes and non-electrolytes, ionization and conductivity, electrodes, and electrolytic cell. 3. We are going to look at electrochemical series. Under electrochemical series, we will look at definition and explanation of electrochemical series. We will look at arrangement of metals in electrochemical series, arrangement of cations in electrochemical series, arrangement of halogens in electrochemical series, and arrangement of anions in electrochemical series. And then we are going to look at the application of electrochemical series. Number 4, we will look at the laws of electrolysis, Faraday's laws of electrolysis, which includes the first law and the second law. Number 5, we will look at what is called preferential discharge of ions in electrolysis. Under this, we will look at the explanation of preferential discharge and, importantly, the factors that influence preferential discharge of ions. Number 6, we will look at the electrolysis of molten substances. Under this, we will look at electrolysis of sodium chloride and also electrolysis of alumina. Number 7, we will look at electrolysis of aqueous solutions. Under this, we will look at electrolysis of water and electrolysis of copper 2 tetraoxosulfate 6. Number 8 is application of electrolysis, under which we will look at purification of metals, extraction of metals, electroplating, production of hydrogen gas, and production of sodium hydroxide. So this is the rundown of this lecture series. Etymologically, electrolysis is gotten from two words: electricity and lysis. Lysis means to break down. So when electricity is passed into a molten substance, molten is the same word as melted. So when you melt a substance that can conduct electricity and pass electricity in there, and this substance is able to break into its respective constituents, or when you dissolve a substance in water to form a solution and pass electricity in there, and the substance breaks into its respective components, we call this electrolysis. So electrolysis is the decomposition of a chemical substance either in molten form or in dissolved form by the passage of steady electric current. Electrolysis has a lot of applications or importance. Number 1, electrolysis is used to extract metals and also used to purify metals. Another importance of electrolysis is that through electrolysis, new substances can be formed. You can use electrolysis to form new substances, to produce many substances. And another importance of electrolysis is production of hydrogen gas. In the principle of electrolysis, we are going to look at electrolytes and non-electrolytes. Electrolyte is any substance, either in molten form or in solution form, that can conduct electricity. Note that these electrolytes must first of all contain ionic bonding. They must be ionic compounds or electrovalent compounds for them to become electrolytes. Examples of electrolytes: sodium chloride is an electrolyte, either aqueous or molten liquid. Another example is tetraoxosulfate 6 acid. We also have copper 2 tetraoxosulfate 6, zinc chloride. All these are electrolytes because they conduct electricity when melted or when in solution form. Non-electrolytes are mainly covalent compounds, but mostly they don't conduct electricity. Examples: urea, sugar is non-electrolyte, etc. Ionization and conductivity. Ionization is the breaking apart of electrolytes into their respective ions. For instance, when tetraoxosulfate 6 acid is dissolved in water, it will break apart into 2 hydrogen ions, and a sulfate ion. So before electrolysis proper, there must be ionization. These compounds will break into their ions, and these ions are mobile. They keep moving about before electricity is switched into the electrolyte. So ionization is the breaking apart of electrolytes into their respective ions, while conductivity is the ability of electrolytes to conduct electricity. As the electrolytes are different, that is how their conductivities are different. Some electrolytes are highly conductive, some are moderately conductive. So conductivity is the capacity of electrolyte to conduct electricity that is passed through it. Electrodes are conductors that are dipped into the electrolytes that is inside electrolytic tank. Electrolytic tank is any vessel or bowl where electrolyte is placed. This is electrolytes, while this container is electrolytic tank. Now, for electricity to pass into this system, you must connect 2 rods, 2 conductors, to a pattern. So what they are serving is the purpose of driving electrons into and out of the system. Now, this particular rod, let's say it is the one that brings electricity into the system. This one that brings electricity into the system is called cathode, and it is negatively charged. It's a negative electrode. The one that is positively charged is actually the one that, through it, electricity leaves the system. It is called anode. So what happens when electricity is passed into the system? The random movement of ions will cease, and these ions will begin to migrate to the electrodes. The cathode is the electrode that brings in current into the system, and it is also the electrode to which cations from the electrolyte migrate to get discharged, because in electrolysis cations behave like nonmetals because they accept electrons. For instance, sodium ion is a cation. It's not the same as sodium atom. Sodium atom, we know, is a metal. It loses electron. Now, when it loses electron, it becomes sodium ion. This sodium ion cannot lose electron. The only thing it does is to accept electron to become sodium atom. And this is the kind of reaction that happens in the electrolyte. So this sodium ion is a cation. It will migrate to cathode and pick the electron. When it picks this electron coming in, it will become sodium atom, which will attach itself on the wall of the cathode. And this is called discharge. If there is anything chloride ion, what it does is to lose electron at the anode and get discharged as chlorine molecule. This acceptance of electron by cations at the cathode is called reduction. Therefore, reduction occurs at the cathode, and cathode is negatively charged, and cations migrate to the cathode. Take note of this. And at the anode, oxidation occurs, since oxidation means loss of electron. Oxidation occurs at the anode, and anions migrate to the anode, and the anode is a positive electrode. Take note of this. So, at the end of this section, we are able to define electrolysis, say the importance of electrolysis, talk about the principles of electrolysis, which include electrolytes and non-electrolytes. We are able to talk about ionization and conductivity, talk about electrodes, which include anode and cathodes. We were able to look at electrolytic tank or electrolytic cell. That is another name. In the next episode, we are going to look at electrochemical series. Now, I'm going to display on the screen a variety of JAMB questions on this particular section of the series. You are going to solve these questions and get back to me before we go to the next series. And do have a wonderful day. Bye.